Hello, in this video, we're going to be talking about limits. Now, calculus is interested in about shoving two things together that we're not allowed to put together. So we want to kind of play the I'm not touching you game, similar to what asymptotes do, where we get really close to touching. But we don't ever quite get there. And we want to see where are we heading towards as we reach a particular value. That is what a limit is checking. Here are limits. So a limit is the value a function is moving towards as the value of x approaches a particular value. So it doesn't evaluate the function at that particular point. It's just seeing where are we moving towards? What sort of direction does this function seem to be going towards as we reach a particular value? So in this thing right here, it would be read as the limit as x approaches c, so that's down here, of f of x equals some number, L. That's our limit. Now, not all functions have limits everywhere, so a function's limit could not exist, so the limit does not exist. We would just write D and E. In order for a limit to exist, is we make two kind of like little mini limits. So we put like this little plusy thingy and a little minusy thingy, kind of like exponent thingies. And what they mean is this is as x is approaching c from the right versus approaching c from the left. So we see if the two directions of where the function is moving, if they're coming towards the same value. If they miss, then the limit doesn't exist. But if they meet, then we have a good limit. So in this problem, we're checking, okay, what is the limit as x is approaching -1 from the right? Yeah, we know it's from the right because it's got this little plus thingy there. So as we move towards here, as our x value gets closer to -1, so at this -1/3, -2/3, -8/9, what is that y value spinning out? So it's like 1/3, 2/3, 8/9. It seems to be up here at +1. So it seems to be heading towards that point right there. The y value the function is spitting out is 1. So this statement is true. If we check this one over here, what is going on as x is approaching -2 coming in from the left? Approaching 2. We approach 2 coming in from the left. So as our x value is 1/2, 1.7, 1.8, 1.9, it seems to be spitting out a y value of 0, a y value of 0, a y value of 0, y value of 0, until it hits 2. We're not going to get quite to 2, but we're going to approach 2. But it seems to be doing 0, 0, 0, 0, 0. So we could assume that as x approaches this, it's not 2. This is false because the actual value of the limit is 0, not 2. In this example, we've got two conflicting answers. One person says the limit as x approaches 1 of f of x is 0, and somebody else says the limit as x approaches 1 of f of x is 1. Well, it's got to be one of those numbers, and we don't know which one. So to determine that, we need to see what's happening as we come in from the left and what is happening as we come in from the right. So if we start over here with this one, as we approach from the left, that's what that little negative thing means. As we approach one coming in from the left, as we move in this direction, we can see that the function is moving up. So our y value is increasing. It's getting bigger and bigger and bigger as we get closer and closer to this x value of 1. The y value is getting bigger. It's heading up towards this thing. It's not going to quite reach there. It's going to get closer and closer to it, but it's never going to quite reach that point. But that's the whole point of a limit, is it's just getting towards it, but it's never quite reaching there. But as we get closer to it, it seems to be reaching this y value up here of 1. So this limit is 1. As we come in from the other side, I'm going to do that in purple. As we come in from the right, this one is heading towards this direction. So as we're at 1.9, 1.8, 1.6, 1.7 is saying 0 and 0. It's not really changing. It's just stuck at 0. It's just doing 0 over and over again. We don't care where it is when it actually reaches 1. We just want to see what's the trend. It seems to be saying 0 over and over and over again. So the limit as x approaches 1 coming in from the right is 0. So it turns out that both of these people were wrong. These are both false. Both of those answers are false because our limit from the left and our limit from the right are not equaling the same value. Since they don't equal the same value, our limit does not exist. The limit as x approaches 1 of f of x does not exist. We have a good left-hand limit right here. The limit as x approaches 1 coming in from the left, that's 1. That's fine. So coming from the right, that's 0. That's fine. We even have a value for our function. We can even say, hey, guess what? F of 1, oh, that's 0, because that's this point right here. But the limit doesn't exist because it's not heading towards that same value. So we have a value of the function, but we don't have a limit for the value. No, wait, we don't have a limit at that point. Oh, we got people arguing again. Oh, they're arguing. This person's like, the limit as x approaches 0 of f of x is 1. And somebody else says, no. The limit as x approaches 0 of f of x is 0. I don't know which one it is. We got to figure it out. Well, but to start that, I want to first say, what is just the function equaling? Not the limit, but what does the function actually do? This doesn't help us determine the limit, but it is still kind of nice to know, to understand that we're not talking about what the function actually does there. We only care about where the function is heading towards as it approaches that point. So f of 0 is this filled in dot right there. It's at 1. As we come in from the left over here, we can see that it's heading down towards 0. As we come in from the right, that's what this little plus thing means. As x approaches 0 coming in from the right, it is also heading towards 0 because they're both heading down towards this spot. In fact, they're both equaling the same value. These two things are true. Since those two things are true, that the two values are equal, we do have a limit at this point. The limit at this point is this value. It has to be that 0. So this person was right. This is true, that the limit as x approaches 0 of f of x is 0. This person is false. They may have been confused in thinking about like, hey, that is what the value the function spits out at 0. It is not, however, the limit at that point. That's our introduction to limits. This is just the introduction to limits. We're going to be playing much more with limits to get a better idea. This is just to get you started and thinking about limits. The important thing I want you to take away from this video is that limits are just where we're heading towards, not where we actually end up when we are approaching a particular value for that function, and that the right and the left-hand limits have to match up in order for us to get a full limit at that point. Thanks for watching. Goodbye.